Okay, so hello everyone, welcome to day 3, or is it 3 or 4, I forgot, but yeah, of this challenge. And I didn't do this challenge yesterday because my electricity situation in my area was really bad. Um, my uh, my battery was like 17% or something, that I couldn't do anything, so that's why I didn't record. I apologize for that. I'll make up that I'll make up that tomorrow. Like I'll do like 3 questions or 4 questions tomorrow. Okay, so today we're doing this question. So this is like a little switch up to the question I normally do. And it's about angular velocity, angular acceleration, tangential velocity. I don't think there's tangential velocity here, but yeah, it's about this. So let's start. The first wheel starts from rest. Okay, so the rest, it reaches angular velocity 1.5 radian per second over a period of 10 second period. Okay, under a constant angular acceleration. Alright, so let's do this. Alright, so this is angular inertial. Angular velocity is 0, and angular velocity after 10 seconds is 1.5 radian per second. Okay, and then the the time, right? The time is 10 seconds. Okay. Alright, so number 1, find the angular acceleration of the Ferris wheel. Okay, so let's do that. So I'll just use the normal normal acceleration equation from the linear equation. So the acceleration from the linear equation is like v minus v inertial over t, right? Or you could say it's delta v by delta t. So we just switch out the v with with the angular velocity. So we just switch out v with angular velocity. I might be wrong because I am very new to this topic, so I'm still learning. But I think this is how it works, right? So and then the acceleration is switched to alpha, which is the unit, the symbol for angular acceleration. Okay, so we will get this. All right. So we want the angular acceleration, so we just put these units into here. Okay, so we'll get 15 divided by 1.5, sorry, 1.5 divided by 10. So you will get 0.15 acceleration, which is radian per second square. So this should be the answer to question 1. And I should add the answer of the number 1 there. Okay, so let's move on to number 2. How many revolutions does it take to make 10 seconds? Okay, so we have to find the displacement, right? So to find displacement, the equation I can recall right now, I know there could be like more easier equation to do this, but just like I said, I'm still very new to this. The equation that I'm familiar with is theta equals to angular velocity, inertial angular velocity multiplied by second, I think, plus 1/2 of acceleration. So I should write this like alpha t square. I think this is the equation here. So we just use this equation to find theta right here, which is the displacement. So basically this will be 0 plus t, which is 10, plus 1/2 alpha will be 0.15, and t, which is seconds, is 10 square. And now just put that into the calculator, and then we will get the answer 7.5 radian, I think. Okay, so we'll get 7.5 radian. Okay, so the full revolution of the circle, so let's go here. so it's going around in circles, right? So the full revolution of the circle in radian is 2 pi. Okay, 2 point is about 2 point is about 6 point something. So I just need to do is just divide this by this, I think. So let's do that. So revolution, so REVOLED. So revolution, or we so one revolution is 2 pi, so 7.5 radian. One revolution 2 pi. 2 pi is one revolution, right? 2 pi is one revolution, so 7.5 will be how many? So that will be 7.5 over 2 pi. And that would get about 1.19, so about like 1.2 revolution ish. So yeah, this will be the answer to this question. So yeah. Okay, so this is for today. It's a really busy day, and don't have really that much time, so I couldn't really do other questions. I would love to do other questions, but yeah. And I'm very new to this topic, just like I said, so I might be wrong. So if I'm wrong, you can correct me, in the comments. I don't mind. I'm still learning. So yeah. See you tomorrow, guys. So goodbye.